Good morning, everybody. This session is titled OCP, Cooling Environments and ASHRAE TC9.9, kind of the roadmap for future collaboration. So today, you have myself, Matt Kokel, who is with AEI and the ASHRAE TC9.9 chair. Mark Steinke with Nvidia. He's the ASHRAE TC9.9 vice chair. Cosimo Pecchioli with BP Castrol. He's the OCP Cooling Environments co-lead. Sean, I'm not going to butcher your name, but Sean, Nvidia, OCP, Cooling Environments co-lead, and Kelly, Isotope, Cooling Environments Immersion Project Industry Liaison. So today, we're going to give you a quick overview of ASHRAE and OCP, and then in collaboration, we'll get into some questions. So what is ASHRAE TC9.9? The title of ASHRAE TC9.9 is Mission Critical Facilities, Data Centers, Technology Spaces, and Electronic Equipment. So everything that you see here today and we're talking about at this conference generally is involved in our facilities. The mission, we're concerned with all aspects of mission critical design, commissioning, maintenance, and sustainability for these different facilities. We're looking to drive common standards, provide efficiency, energy efficiency, resiliency for our different designs. And we're going to also guide the industry in current and future technologies and design, as well as standards for design practices. The scope, all things datacom facilities. So whether that's a processing environment, AI straight up, or communication facilities, you know, server rooms, telecom rooms, that all falls within the scope of TC9.9. And then finally, kind of the system components. So the facility level, meaning chillers, computer room air handling units, cracks, air handlers, controls, that all falls within inside the facilities piece of ASHRAE. And then finally, the IT equipment. So CDUs, rear door heat exchangers, racks, servers, maybe not so much the chips and so forth, but you know, the cooling environment related to the servers. So why are we here? Why are we having a conversation about ASHRAE and OCP? There's a lot of activities between ASHRAE and OCP. There's a lot of standards, a lot of guidelines that OCP uses from ASHRAE and kind of vice versa. There's a lot of people that are involved in both organizations. So the goal is today to kind of expand upon this a little bit. So ASHRAE giving standards to the industry that are guidelines as well as standards that are adopted for codes, right? So like ASHRAE 90.4, the energy standard for data centers. Or how people go through and rate IT equipment. So ASHRAE 127, the method of test for computer room air handling and data processing unitary air conditioners. And we've given a lot of guidelines, right? So there's you know, the thermal guidelines, there's the liquid guidelines, the temperature classifications. So if you've ever seen one of these charts, whether it be a psychrometric chart or the overall chart that lists out the W classes, those are all coming as guidelines from ASHRAE. And then best practices, you know, data center commissioning, design considerations. These are all items that come out of ASHRAE TC9.9 in the membership. We also provide research, so whether that be cold weather shipping, whether that's sea salt contamination or gaseous contamination, what materials compatibility, liquid cooling resiliency, fluid velocity for liquid cooled systems and limits of erosion. You know, these are all pieces that are funded by ASHRAE that the members and or other organizations are performing research on. So why are we here today? As you can see, there's so many different products out in that data, out in the hall that talk about liquid cooling and the changing landscape that AI is impacting the data center facilities. We're seeing higher demand for TDP, wattage of the chips. We're seeing increased density of chips in a single server. And at the end of the day, we need more people to collaborate and figure this out from a technology and from a liquid cooling perspective so that we're giving standard guidance to the industry.
All right, so I will not explain what OCP is because if I had to do that, probably you're in the wrong place. But so the idea of this collaboration is to speed up the rate of the rate of the information actually is divulged and actually first discussed and then divulged. Because we realize that this is an inflection point and the speed in which the technology is changing is actually higher than what we were ready to to discuss. So it's a speed problem and it's a breadth problem. We need to incorporate new ideas and new technologies, and therefore we thought that actually this collaboration is actually what it's needed in order to activate the new opportunities, challenges and opportunities. We will not read these slides because you can download them, so you can have all the details about the slides. And essentially, the benefits that we think that will come from this collaboration is expand the knowledge. The challenge that we see with liquid cooling essentially is a familiarity thing. People see this as a new thing, they are scared, they don't know how to implement it, and our two organizations, we think that we can help with that, and so we are here to start this conversation, essentially. And I think that's the best way that we can do it is start with the panel.
Hello? Yes, working now? All right, I see a few thumbs ups. Yeah, great introduction. We have our distinguished panelists on the stage, and we're just going to dive right into it. So the first question is for Mark and Cosimo, and that's why has this not taken place earlier? So start with Mark.
Okay, I'll start. So there's been a loose association. We've got members in both bodies that participate both in OCP and in ASHRAE. And there was a loose or an earlier attempt to try to have a more formalized relationship there, but I think over time, the need for liquid cooling didn't really exist at the mainstream, so air cooling was there, air cooling advances happened. I think that kind of delayed this inevitability here. Now that we've got this workload and this driver, I think it's driving that urgency for us to get a more tight collaboration.
Yeah, no, I agree. And to build on what you just said, air cooling was such a consolidated and known technology that no one really was. I mean, very few people were looking for guidance on how to do air cool. I mean, it was very well known. When liquid cooling started to become mainstream, people looked at how to do that, and we realized that if you have two organizations saying maybe even the same thing but using two different terminologies, it can be confusing. And so, therefore, here we are to actually try to coordinate that because we have to now.
Yeah, absolutely. We can't kick the can down the road any further. The next question is for Matt, Sean, and Kelly. How do ASHRAE and OCP leverage their unique strengths to solve these challenges?
Yes, I'll start. I think OCP is kind of unique in the sense we've always been able to come up pretty quickly with innovative solutions. I think a good example is the Universal Quick Connect came out the cold plate workstream from Intel, and it kind of got Quick Connect suppliers working together to enable the industry. And there's other examples like logistics and integration of liquid cooled racks, a good example at the L10, L11 level from Vertiv. So with those kind of opportunities, we've kind of tried to accelerate liquid cooling as in spaces where we think it's most relevant. I think combining that with what ASHRAE's done with its foundational building blocks in terms of building data centers is going to be the key. And if we can do that in a fashion that keeps things moving along as fast as possible and keeps up with the AI race that we're seeing now, I think we'll be in a good space.
Yeah, just building upon that, I think the collaboration that we have between OCP and ASHRAE with the different individuals and trying to expand the number of people that are engaged in this conversation is really where we want to end up getting to. And the standards that ASHRAE provides and the guidance, really lends itself well to the community of OCP that is developing products for this industry. And I think the standards that ASHRAE is able to provide and the guidance and research, really lends itself well to kind of OCP and the product development that goes along with OCP.
And I'll just say, with this new team that I'm chairing for the industry liaison team, we're building coalitions across the different standards bodies to facilitate the two-way communication between OCP and the different standards bodies, ASHRAE of which is one of them, to make sure that we are aligned in terms of the challenges that we're facing and that we're able to freely share the strengths and leverage the strengths of the organizations to make sure that we're able to propel the industry forward to meet the challenges of speed and breadth that we talked about in this earlier slides.
Yeah, very well put. So we leverage ASHRAE for its breadth of knowledge and providing standards, and OCP can continue to focus on speed and focus towards solutions. The next question is for Mark and Cosimo. What are the short-term and long-term goals of this effort or initiative?
Well, I think, as you can see in this conference, you can see all of the speed at which liquid cooling is getting adopted and more kind of, let's just use the term mainstream. It's been in existence in HPC and in those types of environments. Here, I think short term, like Cosimo led with the introduction, is we want to just make sure that we have the conversation, we have a good alignment, we don't necessarily duplicate effort. So it's beneficial, I think, to both bodies to have a consorted push into some of the avenues, like, for example, I think we mentioned flow velocities for erosion, right? We want to make sure that we can align, we can help, we can complement each other such that we get a good industry answer. And I think that's the short term, right? So allowing this to adopt more widely than it is already. I think long term, we want to continue that and allow that to expand. I think that's my viewpoint, is we want to expand these ecosystems such that we have good alignment in this market segment, but not only this, but all market segments. We want to elevate that base knowledge of the general industry and allow easier adoption. I think that's the long term. Cosmo.
Everything is said. No, yes, I agree 100%. And to as usual, I mean, to take advantage of what you said and to build on that, as we said at the beginning, the technology, if you think about the infrastructure for data centers, it hasn't changed that much for the last 10, 15 years. I mean, the technology didn't evolve, and so the infrastructure didn't change. Now we are in a situation where the infrastructure, the building, needs to be adapted to the new technology. So now you realize that you need to future-proof the building for what we see now as a technology that is coming, and we don't even know what other technologies is going to come. So again, organizations like OCP and ASHRAE can be, first of all, a place where this discussion happens, because we need the help of everybody to even imagine what's going to happen and how we can accommodate the infrastructure for the new technologies. And then once that we have received all the feedback and elaborated them in a document, our two organizations can help the industry at large distributing this information and helping people that maybe are not fortunate to be part of this conversation, but still they want to know how to future-proof their projects. Again, so we see these as an inflection point. And we need to work together to make sure that we don't build a building that is supposed to last 15, 20, 25 years, and after 5 years is outdated, and you need to invest a lot of money to refurbish that, and then you need to do that again after 5 years. I mean,
Yeah, absolutely. I think as the theme has been for this conference is AI enablement, right? I mean, that has to happen sooner rather than later. But at the same time, we want to make sure we continue to build a wide ecosystem of solutions and no one gets left behind. So this next question is for Sean, Mark, and Kelly. Are there other entities that need to be a part of this effort or initiative?
Yeah, so I'll start on that one again. I think a good starting place that we saw a little bit of reference to earlier in Keegan's talk on the coolants is ASTM and standards bodies like that, where we can try and advance some of the older standards like ASTM D1384 or 8040, where you're trying to see if it makes more sense in a liquid cooling environment as opposed to reusing something from the automobile industry. That's one. And then UL is a great place as well, where I think we haven't really seen the type of evolved standards that we need to accelerate the industry.
Those are great standards or organizations, and I'm happy to share that we have representation in the industry liaison team from those organizations as well. In addition, we have to think about the government part in this. So what types of regulations can make things easier for adoption of liquid cooling? What types of incentives for creating sustainable data centers can be made available to companies that are going to invest in these technologies to have data centers that are not only delivering the power and cooling that's needed for AI, but done so in a sustainable way so that we're not impacting the environment?
No, I think those are excellent examples. Maybe I'll add a practical example. What comes to mind is the IEC. There was an IEC standard that was used to apply a rating for burst pressure. And that has kind of evolved over different generations or different editions. And an unintended consequence of that was the rating was increased to 5 times that burst pressure. And that became a problem in the IT equipment space, and it was hard to satisfy that. And then there was a discussion. I know, for example, they came to ASHRAE to look for guidance. It's just, I think, a lack of that guidance. And I think because it's applicable here, it's applicable at ASHRAE, it's good to have a consorted effort to make sure that we just guide and steer those types of bodies and regulations. So I think just adding to what you guys said, that would be another good example, I think.
And to your point, Mark, I think with that standard that became an industry, requirement, it caused systems that needed to be over-designed, right? So that's a lot of time and cost that may not necessarily have been needed in terms of a safety rating that could have been done at a lower level.
Exactly.
All right, excellent. I think we have time for a few questions. Please walk up to the microphone.
Hello, my name is Natalie Bates. I chair the Energy Efficient High Performance Computing Working Group. I know a lot of you. I am delighted. I didn't know that this was happening. It's fantastic. We've been working with you in high performance computing with both of your organizations. So this is really fantastic. I would like to offer that our direction, our current direction, is focused on mechanical cooling controls. I think the controls component of this, especially with very large, millisecond power fluctuations in the power systems, matched with slower cooling response times, is a really important issue both for high performance computing and for training AI workloads. I would also like to offer 2 things that we've had on the table for a while that neither of you have really embraced, and one is we have a liquid cooling commissioning guideline that we developed, and we've vetted it a bit with ASHRAE, but we'd love to have you guys take that more seriously. We also have the TUE metric, right? So driving forward on PUE to get better clarity for taking out the subsystems from the compute system that actually are facility related. And then actually one more thing, the OPR process, the OPR document, which was, I think, developed by ASHRAE, we have an OPR recommendation for mechanical cooling controls. So anyway, great to see what you're doing. This is fantastic. Thank you.
No, I just want to say that we actually, in the meetings that led to this, we mentioned you and your organization specifically as an organization that we need to reach out. The name of your organization is too complicated to remember, but yeah, exactly.
It's the Energy Efficient High Performance Computing Working Group, EEHPCWG, and we have very strong, yeah, sorry. Wait, I know, we're a bunch of techies, right? So anyway, and we're also more than 10 years old, so, we're like 15 years old, so those were the days when acronyms were popular.
Natalie, I think that to your point, the reason why we're having this conversation about OCP, There are so many different organizations that are developing a standard or a metric or research or different activities that are surrounding this ecosystem of liquid cooling in one way or another. And there's, I mean, you walk out into the hall out there and you can see so many different products with so much different knowledge, so many different directions. We're here today to say that we're trying to, wrap our arms around liquid cooling facility design, standards, guidelines, et cetera, so that we can give much more cohesive knowledge to the industry. Because how do you know what you need to design between the rack and the CDU? Where's the guideline? Where's the standard? I mean, sure, you can go and look at the liquid cooling guidelines from ASHRAE, but it's not going to give you the level of detail that is going to actually help you design that. So I think our goals are really to just embrace it a little bit more, put our arms around it, and develop this as a kind of more consortium type of function than each individual group.
Oh, you've just made my job easier, so thank you.
I would like to say commissioning is really important. So yeah, we would definitely like to talk to you guys more on that. So that'd be great.
And we have another specific challenge, that this industry is made of extremely large companies that think that what they do is the right thing to do and it's the standard. But each of company has something a little different. So we really need to coordinate, and we need your help because this is an elite group of people that can really make a difference. And so, P. Cheney.
I think we have time for more questions. If we have anyone else who wants to walk up to the mic.
I'll follow on with Natalie, another HPC guy. Nick Zubey, I'm from at ARM now, but I've been at HP for 15 years before driving the frontier in large systems. It was very interesting to listen to some of the talks, some of the panels. There's a lot of relearning that we do across the industries. I would just, there's a lot of things, I would encourage you guys to go in the commissioning. It's not just about pump pressures, delta P's, delta T's, and all of these things. There's a lot that has been learned, and it's been published through the HPC WG around, for instance, chemistry. How to follow your liquid loops, how to do coupon testing, how to watch for basically having, for instance, a pH change might mean that you might have an algae growth in your loop that's about to happen. There's a lot of those things around chemistry, and unfortunately, I went into computer engineering because I really hated organic chemistry in college. I've had to learn over the last decade about organic chemistry, how to kill algae, how to manage all of that stuff way more than I would have ever envisioned for. So I really encourage you guys to look at those things, because if you haven't experienced it yet, just wait for it. Well, it's coming for you.
Well, I'll just say I'm somebody whose technical background is a PhD chemical engineer. So I have a lot of experience with fluid flow, with chemistry, with a lot of these different things, especially as it relates to liquid cooling. And so again, that's some of the beauty of, and some of the challenges that we're facing, like for example, in the immersion community, material reliability and compatibility is such an important work group. And so a lot of that work is shepherded by some of the companies that have been the forefront of the immersion cooling industry. You're talking about some of the cold plate challenges, things that happen in the water loop in the data center, and so that's also really critical work that's happening in the cooling environments and the cold plate team. So I think how we can bring all of these work groups together to elevate them to understand the commonalities, the technical challenges, is some of the work that this body is going to address. So thank you for your question.
But I would say, if I had to summarize this into words, we are really trying not to reinvent the wheel 1,000 times and 1,000 different wheels. So let's work together.
I think we have time for just one final question. Damn, I thought he was going to ask. All right. If not, we thank our...
What would you like to see out of ASHRAE and OCP? We're going to ask the audience a question. Step up to the mic, or you can just feel free to answer.
Speaking on behalf of both Keegan, speaking on behalf of both Keegan representing Dow and myself with Jeff Cool Fluids for the glycol-based PG25 fluids. I believe it was Sean that you referenced also very more specific corrosion test methods for the fluids under the applications of the cold plates and the data centers that's more focused on copper, heated copper as a heat transfer surface, and the appropriate temperatures and flow conditions that are present in these systems for the data centers.
Thank you. Appreciate that.
Yeah, I agree. Thanks, David. Yeah, it's a space that I think a lot of folks are familiar with, but in certain areas outside of the data center space. But I think that knowledge base does need to come into OCP, ASHRAE, and come through as guidance, particularly beyond the current guidance that we've given already. Thanks, David. Yeah.
And I think I'll add, and that's part of this discussion, right? There's an RTAR, which is a method of research that we submit for ASHRAE on wetted materials. Sean knows about it. We're working on that. We welcome all participations for that exact purpose, right? And that's the point of this entire panel and the collaboration here.
All right, we are at time, and we thank our esteemed panelists. Thank you so much.